longest wavelength of Lyman series. Okay, the question is calculate the shortest and the longest wavelength of Lyman series. Okay, so I hope all of you are able to see, and I hope all of you are able to you have your notebooks ready and we are ready to work. So first, Lyman series. Lyman series means, do you understand that this is talking about electron jumping from the second shell to the first shell, third to the first, or any higher level to the first? Yeah. Then longest wavelength. Do you understand means least energy? Longest wavelength means least energy. So now, if this is the first level, this is the second, this is the third and fourth and so on, do you understand that least energy will happen only when it comes from 2 to 1? Yes. So I can write 1 by lambda is equal to 109678 into 1 by 1 squared minus 1 by 2 squared. So this we are talking about the longest wavelength. So when I work this out, I will see that 1 by lambda is equal to, this will become 3 by 4 into 109678. Now on some small rearrangement, I can get the value for lambda. Yeah. So if you work it out, you will see that lambda is equal to 911.7 into 10 power minus 8 centimeters, or it is equal to 911.7 into 10 power minus 10 meters. So I can say it is 911.7 angstrom units. This value that is given is per centimeter. Okay, can you work it out and get this value? Please don't get distracted. Please don't think about anything else. Please focus only on this and let us complete it. Yes. If it is done, then let's try to find out what is the shortest wavelength. So longest wavelength is done. I will Baba, you have to do this calculation, Yalini. It doesn't matter. 10 power 10 did not come. Okay, this is wrong. You do and you tell me, can you convert this centimeter to meter? How do you convert centimeter to meter? How do you convert centimeter to meter? So I have just done that, nothing else. So you have to calculate. Yes, there will be test on Sunday. You may decide not to write because if you are busy with your festival, don't worry about it. But there is a test on Sunday. We are thinking about unnecessary things now. We have to focus on atomic structure. I am saying there is a test on Sunday. There is no break on Sunday. You may decide to write, you may not decide to write. That I am leaving it to you. Okay, test is there on Sunday. Test is there. Yeah, can you please work and then find out about this answers for this question? Can you please find out the answer for this question? Can you find out what is the shortest wavelength? For the shortest wavelength, will have maximum energy. So 1 by lambda will become equal to 109678 per centimeter into 1 by 1 squared minus 1 by infinity squared. So from here I will get 1 by lambda is equal to 109678 per centimeter. So from there I can find out the value for lambda. Can anybody find out what this value is and then tell what is the answer? No, Niranjan, energy is not hc by lambda. I don't know, you have been sleeping throughout then. There are different ways of finding it out. I am only trying to find out what is the value for 1 by lambda. You can find out by hc by lambda, you can find out. I have no problem. They have given you this data. So from this data, if you want to find out, that is the only way you can find out. You can sit down and then multiply 13.6 into 1.6 every day and then work. But they have given you a very clear approach here. So let us follow this clear approach. Energy is equal to hc by lambda. Energy is equal to hc by lambda, and lambda is equal to hc by energy. No doubt about it. Find out. I have no issues. Find out. Please find out the value. How you do it is not important. Do it is, that is what is more important. So in many questions, the Rydberg's constant will be given to you. So this is how you have to work with the Rydberg's constant, that 1 by lambda is equal to RH into 1 by n1 squared minus 1 by n2 squared. This is the lower quantum number, this is the higher quantum number. I am saying that energy is equal to hc by lambda. What is energy going to be equal to? 13.6 into 1.6 into 10 power minus 19 into 1 by n1 squared minus 1 by n2 squared. So from here I can get 1 by lambda is equal to 13.6 into 1.6 into 10 power minus 19 divided by 6.637 into 10 power minus 34 into 3 into 10 power 8 into 1 by n1 squared minus 1 by n2 squared. Now this is a constant. This is a constant. Now this constant is what is known as Rydberg's constant. So if you substitute this directly, you don't have to do all these calculations. You can directly approach and get the answer. Otherwise, all our time goes in trying to calculate this value. Okay, so this is how you can find out. Yeah, it is similar. Okay, so this is how you can answer. Then let's move on. Next question. Determine the wavelength of the third line of Balmer series. Determine the wavelength of the third line of Balmer series. Okay, so this is the nucleus. This is 1, this is 2, this is 3, 4, 5, 6. These are the different orbits. Yeah, Balmer series refers to electrons jumping from higher shell 3 to 2, 4 to 2, 5 to 2, 6 to 2, and so on. So if we are talking about the third line, we are talking about a transition from 5 to 2. So 1 by lambda is equal to 109678 into 1 by 2 squared minus 1 by 5 squared. Okay, so the first line 3 to 2, second line 4 to 2, third line 5 to 2. So they have asked me for the third line. So the third line will be this much. So 1 by lambda is equal to 109678 into 1 by 4 minus 1 by 25. So now you can simplify this and get the value for lambda. Okay. So if you can finish this, then we will move ahead. Please work on it. Please don't think about anything else. Please focus. Yeah, 4341 angstrom unit is the correct answer. Yes, so you will have to learn to calculate. Many people think that they will calculate in the exam, but in the exam they are not able to calculate because this is not something that can happen in the exam. So it becomes 21 by 4 into 25. This is equal to lambda. So sorry, 1 by lambda. So lambda will become equal to 4 into 25 divided by 109678 into 10 power into 21. This is in centimeters. Okay, so I can try to work this out. So this is 25 into 100. 4 is 100. So it will work out to be this much. So 1096. So 1096. So yeah, so we can calculate. It is 100 divided by 109678. 109678 into 21. So when you work this out, this will be approximately little less than 5, 4 point something. So when you divide it, it will be less than 4 point something. So go for that answer, which is 4 point something. Okay, go for that answer, which is 4 point something. Okay, so if you can complete it, we move on and we will go to the next type of question. Yeah, next a few questions based on photoelectric effect or otherwise. Okay, a bulb is 10 watt and radiates energy at 40% efficiency. If wavelength is 300 nanometers, how many photons are released? Okay, a bulb is 10% efficient. Yeah, it is wrong. Yeah, we'll finish learning it. If we finish learning it today, if you learn, we'll finish learning this. If you finish learning this, you will be able to do the questions on your own. A bulb is 10 watts and radiates energy at 40% efficiency. That means what? It is 10 watt. If it was 100% efficiency, it would have released 10 watts. But now it is only 40%. So it is going to release 10 into 40 by 100. Okay, so that will become equal to 4 watts. Now it is releasing wavelength of 300 nanometers. So can I say the energy of each wavelength is equal to hc by lambda? So that will give you 6.637 into 10 power minus 34 into 3 into 10 power 8 divided by lambda. Lambda is 300 into 10 power, this is nanometer, so minus 9. Okay, now this is the energy of each photon. Suppose n photons are being released, then the total energy will be this much. So 6.637 into 10 power minus 34 into 3 into 10 power 8 divided by 300 into 10 power minus 9 into n. Now I can rearrange and get the value for n. So I will try to do that. So I can now say that this 3 will get cancelled. So this will become 10 power minus 7. So I will get n is equal to 4 into 10 power minus 7 into 10 power 34. It comes down, minus 34 goes up, becomes plus, into 10 power minus 8 divided by 6.637. Okay, now when I work it out, this will become 10 power minus 15, so it will become 10 power 19, so it will become 4 by 6.637 into 10 power 19. So this one calculation I will have to do and get the answer. Yes, students, please focus on the work. Please don't get diverted. Yeah, it is 1 by 23032. It is correct. Yeah, correct. Okay. So if you, this calculation, if you are doing, it will be like approximately 40 divided by 6.6. Okay. So if it is 40 divided by 6.6, 6 into 6 is 36, carry over 3, 36, 39. So it is 39.6. So 0.4. So point. So it will be 6.0 something. Okay. So you're correct. You correct. 6.027 into 10 power 18 is correct. Okay, so this is how you work out these kinds of questions. Then we'll write down another question. A photon has wavelength 600 nanometer. What is the total energy in 1 mole of such photons? A photon has a wavelength of 600 nanometers. What is the total energy in 1 mole of such photons? A photon has wavelength of 600 nanometers. What is the total energy in 1 mole of such photons? Okay, so let me find out. So energy for each photon, it's hc by lambda. So that is 6.637 into 10 power minus 34 into 3 into 10 power 8 divided by 600 into 10 power minus 9. So for 1 mole into 6.023 into 10 power 23, this will give you the total energy. Yeah. So now I can try to work it out and simplify it. So the 6 and 6 will get cancelled here. So I can just remove that, make it to 6.7. So it is 6.7 into 10 power minus 34 plus 8 plus 23 plus 9 minus 2 plus 9 minus 2, 3 into this much. So it will be approximately 20 into 10 power. This is 7, 30, 38, 4 joules. So that is 2 into 10 power 5 joules. Yeah, this is the energy. Okay, it doesn't matter. I have done approximately. Fine. If you have done that, it is fine. This answer is the best answer. 198 into 10 power 4. 19.9 into 10 power 4 is the best answer. But I have done approximately, so I have got 2 into that. I'm seeing that some people are working, many people are not working, so that way life won't work out. Okay, here is the next question. The work function for a metal is 7.52 into 10 power minus 19 joules. What will be the max Ke of an electron ejected out by a photon of wavelength 360 angstrom units? the work function for a metal is this much. What will be the max Ke of an electron ejected out by a photon of 360 angstrom units? By a photon 360 angstrom units. So let us find out. So the way we go ahead is, we know that energy incident is equal to work function plus half mv square. Energy incident is equal to work function plus half mv squared. So I'll try to find out each one of them. Energy incident is equal to hc by lambda. Okay, energy incident is equal to hc by lambda. So that will give you 6.637 into 10 power minus 34 into 3 into 10 power 8 divided by 360 into 10 power minus 10. Okay, so I can calculate this number. So I'll calculate this number. 3 will go here 120 times. So this 2 I'll remove it, make it 9. Okay, 10 I'll remove it, make it 9. So this is equal to 6.637 by 12 into 10 power minus 34 plus 8 plus 9. So this is 17. So this will give you 17. So minus 17. So 12 divided by this. So I will make it 663.7 by 12 into 10 power minus 19 joules. So this one calculation I will do 6 5s 30, 6 5s 12 5 60, again 12 5 60, 37, so 3. So it is 55.3 into 10 power minus 19. So this number here is 55 into 10, 55.3 into 10 power minus 19. This number here is 7.52 into 10 power minus 19. So they are asking you what is the maximum Ke. So Ke will become equal to, if I simply subtract those two numbers, so 55.3 minus 7.52, 7.52. So this will give me 8 here, this will give me 7 here, this will give me 7 here. So 47. So it is 47 point, yeah, so it is 47 point something. So 47.7 into 10 power minus 19 joules. Please work out these numbers. Unless you work out these questions, there is no way you will learn. Just by listening, nobody has ever learned this. Please try to work this question. I will wait for some time. Yeah. Okay, that's fine. That's fine. Okay. Yeah. Don't worry about it. See, ultimately you will be, I am okay with it. You can take 6.6. There is no problem. Ultimately, if the answers are very close, only then we have to go for more and more precise values. Usually the answers will be a little far away. So if the answers are a little far away, then it will work out. But if the answers are very close, then we have to go for the exact values. Okay. Then next question. Photoelectric emission is observed for frequency 1 and 2 of incident radiation. If the maximum KEs are in the ratio 1:k, then find the threshold frequency. Option A, option B, option C, option D. Photoelectric emission is observed for frequency 1 and 2 given, nu1 and nu2. If the maximum KE is in the ratio 1:k, then they are asking you to find out the threshold frequency. So try for a few minutes and then I will work it out for you. Yeah, please work this out. Okay, good. Yes, Akif, good. Yeah, 5553 can be approximated, but again, Harini, it all depends upon the options. So H nu1 is the first energy. This is equal to H nu naught plus Ke. Suppose it is okay, Ke, or I'll better say it as X. In the second case, H nu naught is h nu 2 is equal to h nu naught plus k into x. Okay, because it is given that the ratio is 1:k. Now my objective is to find out nu naught. So how can I do that? By solving them simultaneously. So I'll multiply k here and then I'll subtract them. So I will get k nu 1 minus nu 2 into h is equal to h common nu naught common k minus 1. So now I'll rearrange, h will get cancelled and there simply nu naught I will get k nu 1 minus nu 2 divided by k minus 1. Okay, lot of questions come from this kind of logic. Very, very, very important to understand this. Yeah, what did I do? I wrote the conservation of energy equation first. I wrote the conservation of energy equation for the second, and then I simply tried to solve for nu naught simultaneously. So I multiplied the first set of equations with k, subtracted them, got rid of x, and then got the value for nu naught. Okay. It is from the same element. Because it is the same element, only because of that nu naught is the same. There is only one element, two radiations. Radiations are being given from the same element. Radiations are emitted from the same element, so it will be the same. Okay. Yeah, if it is understood, here is the next question. Here, a photon of wavelength, a photon of wavelength 4 into 10 power minus 7 meters strikes a metal surface. The work function of the metal is equal to 2.13 eV. First question, or only one question, what is the energy and velocity of electron? Okay. So this is a question again based on photoelectric effect. A photon of wavelength 4 into 10 power minus 7 meters strikes a metal surface. The work function is equal to 2.13 electron volt. What is the energy and velocity of the electron? Okay. So how do we go ahead with this? So the way we can go ahead with this is first find out the energy of the photon. So that will give you 6.637 into 10 power minus 34 into 3 into 10 power 8 by lambda, 4 into 10 power minus 7. So when I simplify this, it will work out to be 6.637 into 3 by 4 into 10 power, this goes 15. So 10 power minus 19 joules. Okay, so this is the energy of the photon. Next, the work function is given to me. So, but I don't like electron volt because this is in joules. So I can do two things: convert this to electron volt and give the answer in electron volt. So now it all depends on how the answer is. So I will do both. So first I'll convert this to electron volt and then work. So if I convert this to electron volt, it is 6.637 into 3 by 4 into 1.6. So 10 power minus 19 will get cancelled. So this will become again get cancelled. So it is of the order of 3 electron volt. Okay. So the incident energy is 3 electron volt. This energy is 2.13 electron volt. So kinetic energy of electron is equal to 3 minus 2.13. How much is that? 0.87 electron volt. Okay, so the kinetic energy of the electron is 0.87 electron volt. Once I get this, I can answer in joules by 0.87 into 1.6 into 10 power minus 19. Only thing is, this one calculation, you guys have to do it exactly. So if you want me to do it exactly, here 16 force is 64, 16 force is 64, so I have 23, 16 once 16, 16 once 16, so so it is 77, so 16 almost 5 times. Okay, so 4 will go 1.04 times, into 3 will give you 3.12, so it is almost 3.12. So this is not 3, but it is 3.13. I will make it, so that overall it will be 1. So the answer is this much. In joules, this one is, I will say it is 1 electron volt. So the kinetic energy of the electron is 1 electron volt, or in joules, it is 1.6 into 10 power minus 19. Once you get this value, then we can find out half into m into v squared is equal to this much. So from there I can get the value for V. Okay. Okay, only few guys are working, the others are not working. One last question we will work out. Electrons are emitted with zero velocity from a metal surface which is exposed to a radiation of wavelength 6,800 angstrom units. Okay, electrons are emitted with zero velocity. Zero velocity means h nu is equal to h nu naught plus 0. So what can you infer? Nu is equal to nu naught. Now they are asking you for two things. One, threshold frequency, and second thing, work function of the metal. So we can answer both of them. So threshold frequency will become what? Frequency f is equal to c by lambda. So that is 3 into 10 power 8 divided by lambda. 6800 into 10 power minus 10. So work it out. So this number will give you the answer. So if I work it out, this will become 10 power minus 8 goes 10 power 16. So it is becoming 3 by 68 into 10 power 16. So I will make it 300 by 68 into 10 power 14. So now when I work this out, excuse me. So now when I work this out, it will be 300 by 68. We can divide it by 68 4 times. 8 into 4 is 32, carry 3, 24, 27. So 280, again 4. So approximately 4.4. So it will work out to be 4.4 into 10 power 14 hertz. Unit of frequency is hertz. So 4.4 into 10 power 14. So that is the threshold frequency. That was the question. Then they also asked for the work function. So I can find out the work function by simply h into f. So that is 6.637 into 10 power minus 34 into 4.4 into 10 power 14. So now I can find out what this is. So this will give me the answer in joules. So yeah, work it out. 66 into 44, 24. 24 carry over 2, 48, 50 carry over 5, 29. So it works out to be 29.04. So 2.904 into 10 power minus 19 joules. So this will be the answer. Okay. So I hope you are able to understand how we are working. Yeah. Explain what? Which part do you want me to explain? Yeah, I will show the slides. I'll show the slides. 2 minutes. So F is coming 4.14. Yeah, previous sum I didn't find out velocity. You have to find out velocity. They didn't tell the teacher has to find out. They said the student has to find out. This is the previous question. So this is the thing. H nu is equal to H nu naught plus kinetic energy. So now they are saying kinetic energy is 0. So kinetic energy is 0 means the frequency corresponds to threshold frequency. Okay, the frequency corresponds to threshold frequency. So if frequency corresponds to threshold frequency, then my job is done. So they are asking me for threshold of frequency. Wavelength is given. So all that I have to do is convert the wavelength to frequency. How do I convert? F is equal to C by lambda. So from there I get it. So it seems it is 4.41 into 10 power 14. Up to you. No, not at all an issue. Okay. Then I worked it out. This was the 11th slide. Then I worked out the next part. They asked what is the energy. So energy is simply h into frequency. So I just multiplied them and then I got this much. Okay, so going back, this is the first slide. This is the first slide. This is the second slide. This is the third slide. Fourth one. Fifth one. Fifth one for some more time. Sixth one. Seven. Eight. 9. 10, I said half mv squared, you find out. Half mv squared was equal to energy. So V is equal to 2 times energy by m root over. So all the values are known to you. You just have to substitute and then get it. This is 11. This is the 12th one. Okay. If it's a regular feature, you will have your maths tests. In the book, the value of Planck's constant is given as 6.626. Yes, please apply what is there in the book. I always keep telling you that I can't remember numbers. Every number will be given to you in the exam. Yesterday's homework not yet uploaded because of the festive season. We said we will just wait for 1 or 2 days and then we will apply. Okay, but mass is not given. So how we can find out? In every exam, they will give you. Okay, mass is 9.1 into, but they'll give you the values. Don't worry about it. Always they will give you the values. If they won't give you the values, it will be treated like a wrong question. So everybody will get marks for it. So tomorrow, if there is a maths test planned, it will be there. But tomorrow, 10 to 11, there is a very interesting talk by one of our KVPY scholars who finished her education at IIC Bangalore and now she has gone abroad. So she will be talking to us tomorrow, and the program is not at 12:30 because she's in US. The program starts at 10 o'clock. So tomorrow you will have 2 sessions. One 10 to 11 you will have a session, and one 12:30 to 1:30 you will have a session. So 10 to 11 is a session by this student who passed out of IIC Bangalore, and then now she is not here. So her timing at 10 to 11 will work out. Then the other boy will speak to us at 12:30. So 12:30 is a NIT Trichy alumni. So you guys can decide. The links for the 10 to 11 will be sent today. They would have already been sent by now. Okay. If the maths test will not be there tomorrow. Tomorrow there is no maths test. Yeah, velocity is correct. I have the answer. It is correct. After finding out the so in the last sum, yes, you have to find out the energy. Please do not say that teacher has to work out everything on the board. Yes, tomorrow there is no maths test. Okay. Okay. Your time will come. You don't have your medical exam tomorrow, right? We will do it well before your medical exam. There are a lot of other things for you to know. Please know about it. Then we will discuss about medical. Don't worry. There will be no maths test tomorrow. When it will be, I won't say. It will be on Monday. Yes, Sunday test is there. This is the first slide. Okay, Sunday test is there. Please don't skip that. Okay, yeah, bye. Thank you. Sixth slide. Yeah. Sixth slide. I have shown Idris. I have shown all the slides. I have shown now. Okay, bye bye. Again, you guys are, I don't know what is the problem. 11th is here. 11th is here. 12th is here. First is here. Second is here. Third is here. Fourth is here. Fifth is here. Sixth. 7. 8. 9. 10. 11. 12. Okay. There is no maths test tomorrow because it's a holiday. There is a talk. We are fixing up a talk at that time. So there is no maths test. Sure. Thank you. Thank you. See you guys again. Tomorrow, please attend the session 10 to 11. There is a session. Okay. Then again, 12:30 to 1:30, there is a session. Please attend both of them. Yeah. Thank you.